Hi guys, my name is Brian. That's Kel and that's Kevin. And as part of the data science working group, we wanted to answer the question why traffic fatalities increased in 2015. And the Department of Transportation keeps track of basically every single fatal accident that happened on US highways and kind of, who was involved, what were the conditions of the accident, a ton of different variables about basically everything you can imagine. And in 2015, 2,300 more people died than in 2014, which is actually the largest single increase since 1966. And of course, the Department of Transportation wanted to know why. So they actually sent out this call to action for anyone who was kind of like able to try and understand like why fatalities had went up so much. So we had a wealth of data, and we kind of like started with like, okay, traffic fatalities went up, like what caused it? And so we were like, maybe people were on their cell phones more, maybe it was warmer, maybe people were bicycling more and getting run over more. And we really couldn't find anything. We used a bunch of different methods, looked at a lot of different variables, and couldn't really find anything. But we then asked a different question, which is, what if the roads just didn't get any more dangerous and just people were driving more? And seems like, a lot more people died, like that seems crazy, but if you actually adjust the fatalities by the number of miles driven, you can see that since 2009, the rate has fluctuated a little bit, but it's been kind of within kind of a narrow band. But this is still like a pretty serious, thing to look into, and you don't want to just be like, well, I looked at the chart and it looks kind of flat. So we actually applied statistical techniques to this. And we also used two different approaches, Kel and Kevin respectively, and we looked at a bunch of different variables. So we didn't just look at total deaths, we wanted to see like maybe there were trends within certain subgroups, like just bicyclists or just people who were involving drivers between 25 and 44. And we picked these variables because they saw the biggest, as a group, they saw the biggest increase as a proportion of all the different subgroups. So I'll let Kel describe the first approach here.
Thanks, Brian. So what we have here is we have a database of all the deaths and all the cases that happen for particular dates. And we have then we combine that with another data set, which is an estimate of the amount of vehicle miles traveled in this country by various states. And we combine these two data sets, and we found that there's a very high correlation between, of course, the vehicle miles traveled and the number of deaths. In other words, the more you drive, the more likely you're going to die. We did a so you can see here we just did a simple training linear regression on the green training data, and then that was for pre-2015, and then for 2015 we tested to see how well it performed, and it was like 0.91 and 0.92 R squared, just R squared, which is 92% explanatory power in that regression. So that was the largest variable, significant variable we found. The other thing is these other ones, you would think that under 16 you would have more deaths per vehicle miles traveled, and that looks really weird. But the reason why that's weird is because that subset of drivers makes up a very small part of the population. So they don't really drive that much, so it's not reflected in that vehicle miles traveled for them. It's for the whole country. That's the only way we got the data. So in actuality, they probably have a much higher number. And also, bicycle deaths has a 0.72 R squared with vehicle miles traveled. So again, the more people drive, the more bicyclists die. So those were my findings with that.
All right, so I was in charge of the second approach. The second approach I used is something called interrupted time series. So intuitively what it does is it regresses a line on pre-intervention trends, and we compare the pre-intervention trend with the post-intervention trend, where post in this case is 2015 and beyond. And so I'm an economist by training, so these are normal tables for us. But the coefficient that you guys should be interested in is post, so these 5 here. And the top row are the dependent variables. And the dependent variables are the same as in Kel's approach. And as you can see, with the standard errors, the coefficients are insignificant because the confidence intervals contain 0. And so what this means is that compared to 2015 compared to pre-intervention time trend, there's almost this insignificant difference. That's it.
Thank you. Now, basically what we found is we used a couple different approaches, and neither of them showed kind of any significant uptick in any of the categories we looked at or for the total driving population as a whole. So basically, even though the deaths went up, they weren't kind of abnormally high compared to when you assume that the number of people have driven. And while that's bad that they're not getting better, at least things aren't getting worse. And the last thing was that because all these techniques will work when we had 2016 data. So when this 2016 data gets released, we'll also apply this. We can basically plug them through the same models and see if the same thing holds. And that's it. Thank you.
So in the previous slide, how did you guys create the previous trend? What statistical technique did you guys use?
I mean, we had time series data, so I just encoded each year as a numerical value. So, well, and also we separated by state as well. So each state had their own individual time trend, and then we had, like, for example, year 1, year 2, year 3, year 4. No, we didn't use ARIMA. It's segmented regression, so we're just regressing 2 different lines essentially and comparing those two.
Yeah, I tried ARIMA. It didn't really give me anything good, so I didn't include it. Well, I mean, it's basically when you're doing ARIMA, you're looking for correlated temporal correlations, and while it did exist, it wasn't very explanatory. You know, it didn't explain which variable was causing that. That's more like a like a forecast where you're looking at the trending of data, and whether this kind of like goes out of the trend or not. And we didn't find anything conclusive with that, but we did find a lot in terms of the explanatory exogenous variable, I guess. Okay.
Have you guys tried plugging in gas price to see if it also correlates with miles driven? Seems like a big change from last year too.
Yeah, there are models. Basically, the Department of Transportation looked at all the different things that are kind of correlated with deaths and like unemployment rate, temperature, and they found that gas price is I think it's 40% explanatory, where vehicle miles traveled is 90%. So we think it causes more miles to get driven, which is the thing that causes more accidents to happen.
It sounds like you guys basically answered the question. So has there been any response, or have you published it, or?
We haven't published it yet, but we are this week.
Okay.
And so hopefully we'll get some good feedback on that.
Look out for it.
So after number of miles driven, were there any other features that you identified that had high signal that signaled whether there were lots of traffic fatalities?
One thing was temperature was a good explanatory variable, only in that the seasonality of the temperature explained the seasonality of the deaths and the vehicle miles traveled. So people tended to drive more during certain times of the year, and it's probably correlated with the seasonality of the seasons. So they're highly correlated variables.
Hi, were you just looking at fatality data or also injuries? That doesn't result in fatalities.
Yeah, the data only does capture injuries, but only injuries in which there is at least one fatality. So we don't have any. We don't have any things with accidents where there are only injuries or accidents where there are no injuries, and that's just the data set That's kind of just the most comprehensive data set.
did you have data available to you on ride sharing and whether there were professional drivers or not involved in these accidents?
We don't have any ride-sharing data. I would say that a lot of the most interesting papers that are out there are done using insurance data because you have a lot more data points. There's a lot of fender benders and stuff that get recorded in that. And I know that Uber is saying that they're promising to release some data. So hopefully that data gets open because for a lot of questions we wanted to answer, even though there's a lot of fatalities in the US, if you're trying to look at individual, like what causes them, it's very hard to pull that out because in the big scheme of thing of all the people out there, it's actually not that many people are involved in fatal accidents. So, thank you guys.